Assalamu alaikum guys, welcome back. Okay, so now in this video we are gonna talk about empirical formula calculation and molecular formula calculation. Remember in the previous video I told you all the formulas of moles and the definition of moles, and I told you that empirical formula and molecular formula are also included in that chapter, the calculation basically. And apart from this, percentage yield and percentage purity are also included. So percentage yield and percentage purity will be done most probably in the next lecture, and in this lecture we are doing empirical formula and molecular formula calculation. So empirical formula, first of all, this is lecture 12 by the way. Now empirical formula, how do we calculate the empirical formula? What is empirical formula by definition first? So first of all, I gave you the definition of empirical formula way before in the previous lectures, that empirical formula by definition is the simplest formula representing the simplest whole number ratio between in between the different carbon atoms which are present in the molecule of that particular compound, right? So now over here this empirical formula is the simplest formula basically. Now the three steps that you follow, that you have been following in O levels as well, and now here as well, this is just a revision of that O level stuff. Now how do you calculate the empirical formula? So there are basically three simple steps. First one is calculating the mole ratio, the second was is calculating the simplest ratio, and then finally getting your empirical formula. Okay, the three steps. Now for example, this is an example question over here in which I have been given three atoms. I have been told in the question that there are three atoms, a carbon, hydrogen and oxygen present in a compound, and these are the different percentage compositions of carbon, hydrogen and oxygen present in that compound. That is 40% of that compound's molecular formula or empirical formula is made up of carbon, 6.67% is made up of hydrogen, and 53.3% is made up of oxygen atoms. And I need to calculate the empirical formula. So now the very first thing to do is to calculate the mole ratio. How do we calculate moles? Remember in the previous video I told you that moles are calculated using the formula given mass in grams divided by the molar mass. Over here we don't have the mass, but rather we have the percentages given. You can directly, only in case of empirical formula calculation, you can directly use these percentages and divide them by the molar masses to get the mole ratios, okay, because it's a ratio, right? So even if you convert the percentages into grams and then do it, or do it this way, will give you the same ratio, okay? So that's why I'm doing it directly, and you are also advised to do it directly, okay? So the 40%, assume it to be the 40 grams divided by 12, okay, because 12 is the relative atomic mass of carbon. Then 6.67% of hydrogen is there, right? So divided by 1, because that's for hydrogen, and then for oxygen divided by 16, okay, the percentage composition. And these are the answers I got: 3.33, 6.67 and 3.33 mole ratio is given over here, okay, for carbon is to hydrogen is to oxygen. Now this mole ratio needs to be converted into a simplest ratio, right? So for the simplest ratio, what you do is you actually take the smallest number. In this case it's 3.33, right? 3.33 is the smallest in all of these. Now, and you divide each of these numbers by that smallest number. So 3.33 will get divided by 3.33, 6.67 will get divided by 3.33, and 3.33 will also get divided by 3.33, and as a result, when you solve it using your calculator or just solve it mentally, you'll get a ratio of 1:2:1. Okay, this is the simplest ratio you get, and that's it. That's all you need. Because what is empirical formula? It's just showing us a different ratios of different atoms present in the formula of that particular compound. So in this formula we've got the three different types of atoms: carbon, hydrogen, oxygen. The ratio of carbon is 1, so 1 carbon atom. Ratio of hydrogen is 2, so 2 hydrogen atoms. Ratio of oxygen is 1, so 1 oxygen atom, and this is our empirical formula for this particular compound. Now this was the calculation of empirical formula, and usually it's for 3 marks, okay, the entire calculation. It is very rarely asked, but it is asked in the past papers as well, and has been heavily asked in your O levels as well. Okay, then after the empirical formula, comes the second question of the examiner, the second very frequent question, how to calculate the molecular formula of this particular compound given the molecular mass. The examiner will give you the molecular mass, okay, relative molecular mass, basically the molar mass, which in this case is 180, and will ask you to calculate the molecular formula for this compound. So this is how you calculate the molecular formula. This empirical formula is going to get bracketed by an integer n. Okay, this integer n, what it implies is that when you multiply this value of n by each of these atoms at the base of the empirical formula inside, you'll get your molecular formula. As simple as that. Now let me calculate the value of n first, and then I'll explain how we get the molecular formula. Okay, we've been given the relative molecular mass, or the molar mass, right? Now this is given. This empirical formula can be used to calculate the empirical formula mass. Okay, this EFM stands for empirical formula mass. So 12 atomic mass of carbon plus 2 atomic mass of hydrogen, 2 hydrogen atoms, so that's why 2, and plus 16 because 1 oxygen atoms, and we get an answer of 30. Now this 30 can be used to calculate the value of n, because n can be calculated using this ratio, molecular formula mass divided by empirical formula mass, and this is something you guys need to learn and remember. And as you do that, the 180 will get divided by 30 and you get a value of n, which is an integer, and most probably you will get an integer as, okay, and now this is a 6. This 6 will get multiplied by each of these atoms inside. Okay, they're basically, the atoms of carbon in here are 1, right? 1 carbon atom is over here, 2 hydrogen atoms and 1 oxygen atoms at the base, basically the atoms written at the base. Okay, now it as the subscript. So now this 6 when gets multiplied by the carbon, it will give you C6. This 6 when multiplied by the 2 hydrogens, so it will give you a 12, and this 6 when gets multiplied by the oxygen will give you 6. So C6H12O6, you guys know what this formula is. This is the formula for glucose. Okay, if you have biology, you must know this formula. This is a molecular formula for glucose, and this is how you convert your empirical formula into molecular formula using molecular formula mass. In the next video, we'll be talking about percentage yield and percentage purity, and that's it. Thank you so much.